Okay, here is an example from the textbook for simplifying complex rational expressions. And the textbook suggests that you find your common denominators for your numerator and combine the two fractions, and then you do the same thing for the denominator. And then once you do that, then you use the flip and multiply, and the denominators will cancel out, and you're left with your answer. I have a different method. My method is getting rid of the fractions from the start. So what I want to do is I want to take this complex rational expression and I want to look at what is a good common denominator for both the fractions in the numerator and the fractions in the denominator. And they made it easy for us because in the numerator we have a 3 and a 5 as our denominators, and in the denominator we have a 3 and a 5 also. So when I multiply these together I get 15. So what I'm going to do is I'm going to multiply the numerator and the denominator by 15. Now I can multiply the numerator and the denominator both by 15 because when I do that, it's the same as multiplying by the number 1. So it doesn't really change the value of this expression, but it will allow me to simplify it without having to find combining these fractions in the numerator and the fractions in the denominator. So when I multiply the numerator by 15, I'm going to multiply each fraction separately by the 15. I'm going to distribute the 15. So the first thing I'm going to do is I'm going to multiply the numerator by 15, and that is going to get rid of my fractions. So you can see that I've distributed this 15 to the 1/3 in the numerator and the 15 to the 2/5 in the numerator, and I've done the same in the denominator. And what this will allow me to do is I can cancel out my denominators. 3 goes into 15 5 times, 5 goes into 15 3 times, etc. So here's what I get when I multiply each of my fractions by 15. So when I multiply 1/3 times 15, 1/3 of 15 is 5. Or another way of thinking about it is 3 divides into 15 5 times the numerator of 1 gives me 5. Then I have 15 plus times 2/5. 2/5 of 15 is 5, dividing into 15 is 3, and I multiply that by 2 to get the 6. So in the numerator I have 5 plus 6, the denominators have disappeared, and I have a very simplified numerator. I do the same thing to the denominator. 5 goes into 15 3 times 2 is 6, 3 goes into 15 5 times 1 is 5. And now I have a very simple problem where I have a numerator of 11 and a denominator of 1. And this simplifies down to the number 11. So this is an alternative process to the one explained in the book.